We are going to be looking at how to add and subtract fractions and mixed numbers. When you're adding or subtracting fractions, you want to make sure that you have common denominators. You want the bottom numbers to be the same of the two fractions. As long as the denominators are the same, for example, in number 1, what you're going to do is either add or subtract the numerators, and then we keep the denominator the same. Since these are both 13 on the bottom, I can add the top numbers and get 11. And then we keep the denominator the same, and that would just be 13. Now 11 over 13 doesn't simplify, and so we keep that as 11 over 13. For the second one, we're subtracting. The bottom numbers are the same. That means we just subtract the top numbers. 16 minus 14 is 2. And then we have 30 in the denominator. 2 over 30, it will reduce by 2. If the top and the bottom are both even numbers, we know that it at least can be reduced by 2. So I can divide the top and bottom by 2. And 2 divided by 2 is 1. 13 divided by 2 is 15. And that gives me 1 over 15. That is how we work these if the denominators are the same. If you notice in these next few examples, the denominators are not the same. That means that our first step is to get the bottom numbers to be the same. Now we only do this when we are adding and subtracting. If you are multiplying or dividing fractions, in our earlier video, we do not worry about common denominators. It's just when you're adding or subtracting. And so if I look at these bottom numbers here, I have an 8 and a 2. I want to make those to be the same number. And when we're doing that, we're thinking about least common multiples. And what that means is I take the denominator of the first one, which is 8, and I'm just going to list out a couple of multiples of 8. And when I'm talking about a multiple, what I mean is that I'm multiplying that bottom number by 1, by 2, by 3, by 4. That's how I get multiples of 8. 8 times 1 is 8. 8 times 2 is 16. Times 3 is 24. Times 4 is 32. And I might just list out a few. Sometimes you may have to list out more to find it. I'm just going to list out a few to start with. Then I take the bottom number, which is 2, and I'm going to list out multiples of 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And I'm just listing out a couple of multiples of 2. And I'm going to compare both lists. And my least common multiple, or my least common denominator, is going to be the smallest number that occurs in both lists, which in this case it would be 8. 8 is the smallest number that occurs in both lists. That means 8 is my common denominator. It's my least common multiple. You don't necessarily have to do this every time, but if you're having trouble finding the common denominator, sometimes it's helpful to see it written out in both lists. It makes it a little bit easier to see. This means that I want my denominator to be 8. In both of my fractions, I'm going to get my bottom number to be 8. If I look at this first fraction, it's already an 8. That means I don't have to do anything with it. I'm just going to bring it down. It's already what it's supposed to be, is an 8. Now this 1/2, I still have a 2 on the bottom. It's not an 8. So I need to think, what can I multiply 2 by that would give me 8? 2 times what gives me 8? And that would be 4. Once I find that, I'm going to multiply the top and bottom by 4. I want 8 to be on the bottom. The only way to get 8 to be on the bottom is to multiply it by 4. If I multiply it by 4 on the bottom, I have to also multiply it by 4 on the top. That gives me 7/8 minus 4/8. Now I have my denominators the same, which means I can subtract the top, keep the bottom the same. Three divided by 8 is not going to reduce. There are no factors in common. So this is my solution, 3/8. If I look at number 4, again, I have the same thing. I have denominators that are different. So I'm looking for the least common denominator, the least common multiple. What's the smallest number that's a multiple of 10 that's also a multiple of 6? And so if I'm not sure, again, I'm just going to start listing out multiples of 10. 10 times 1 is 10, times 2 is 20, times 3 is 30, times 4 is 40, and I could go on and on. And then I'm going to list out some multiples of 6. Times 2 is 12. And I'm just kind of listing them out in order. Times 5 is 30, times 6 is 36, and again, we could kind of go on and on. But if I notice, there's a number that occurs in both lists, and that's 30. 30 is the smallest number that's a multiple of 10 and also a multiple of 6. So 30 is my common denominator. Again, you don't have to list those out, but if you're having trouble finding it, it can make it a little bit easier to see. All right, this means I want my bottom numbers to be 30. If I'm looking at this first fraction, 9/10, I want the bottom number to be 30. So what could I multiply 10 by that would give me 30? 10 times what would give me 30? And that would be 3. That means I'm going to multiply the top and the bottom by 3. 9 times 3 is 27, and then 10 times 3 is 30. So this is my new fraction, 27/30. I want to do the same thing with the second fraction, 5/6. I want its bottom number to be 30. So I need to think 6 times what number will give me 30? What can I multiply 6 by to get 30? And that would be 5. That means I have to multiply the top and the bottom by 5. And that is 25/30. All right. So I have 27/30 minus 25/30. When I subtract, that gives me 2/30. Because I subtract the top and I keep the bottom the same. Now 2/30 is going to reduce. I can reduce that by 2. And I get 1/15. For my final answer, I get 1/15. For number 5, we want to do the same thing. This time we're adding the fractions together, but they still have different denominators. I want to make those have common denominators. So I'm looking for a multiple of 4 that's also a multiple of 3. And my common denominator would be 12 for this one. And we could list them out, list out your multiples of 4, list out your multiples of 3, and 12 should be the smallest number that's in both lists. Okay. If I want 4 to be a 12, what can I multiply 4 by that would give me 12? And that's going to be 3. That means I have to multiply the top and the bottom by 3. And that gives me 9/12. All right, and so then I want to do the same thing to the second fraction. I have 1/3. I want to make that 3 be a 12. In order to make that 3 be a 12, I need to multiply it by 4. And I would multiply the top and the bottom by 4. And that would give me 4 over 12. When I add those together, I get 13 over 12. I keep the bottom the same. Now, this does come out to be an improper fraction. And so on the last video, when we looked at multiplying and dividing, we talked about that if you start with just regular fractions, there's no mixed numbers, it's okay to leave your answer as an improper fraction. Or if you wanted to, you could do long division and change this to a mixed number. Either way. However, if you notice down here, we started with mixed numbers. And so if you start with a mixed number, you'll want to end with a mixed number. Okay, so for this example, it's okay to say 13 over 12 or to change it to a mixed number. But in just a minute, when we get into mixed numbers, we would want to do that extra step and convert those to mixed numbers. All right. So that is adding and subtracting with just regular fractions. These next few examples are going to deal with mixed numbers. And anytime when we're working with mixed numbers, we're going to change them to improper fractions. That's going to be our first step. Anytime you have a mixed number and you're wanting to do any kind of operation, add, subtract, multiply, or divide, we're going to change them into improper fractions. Now, there is another way that you could add or subtract these, and that's where you add or subtract the whole numbers, and then you do the same with the fractions. But our method is going to be to change them to improper fractions first. So I would multiply 6 times 5 is 30, and then we add the 3 to get 33. And then we keep the bottom number the same. And we looked at this a little more closely in the previous video. So if you wanted to go back and look at those, that might be helpful. And again, to change this to an improper fraction, 4 times 2 is 8. We add 1 and make that 9, and we keep the bottom number the same at 4. So now I'm looking at 33 over 5 minus 9 over 4. Once we get to this step, it just becomes like the problems we did above. We just want to get common denominators, and then we're going to subtract the numerators. I'm thinking about what's a common denominator between 5 and 4, and that would be 20. In order to get this first fraction, the bottom, to equal 20, we need to multiply it by 4. And I would say 33 times 4 gives me 132. And then 5 times 4 is 20. And I'm subtracting. And I want to look at the second fraction and think, what could I multiply this 4 by that would give me 20? And that would equal 5. So I'd want to multiply the top and the bottom by 5. 9 times 5 is 45, and then 4 times 5 is 20. My new fractions are 132 over 20 minus 45 over 20. And I would subtract and get 87 over 20. We would need to change this improper fraction into a mixed number, because we started with mixed numbers, so that means we want to end with a mixed number answer. And remember, to change an improper fraction into a mixed number, we use long division. And again, we did a lot of these in the previous video, so if you've forgotten how to go from improper to mixed number, you may want to go back and watch the beginning of that first video. But I'm looking at how many times will 20 go into 87? How many times will 20 go into 87? And that would be 4. 20 times 4 gives you 80. And when I subtract, I get 7. And we want to change this and take these values and put them in mixed number form. So I start with 4. It went 4 whole times, so 4 is my whole number, and 7 over 20. 7 is my numerator, 20 is my denominator. 7 over 20 is not going to reduce, so this would be my final answer. If you tried to say 87 over 20 on the quiz or the test, it would count that wrong because it needs to be back into mixed number form. If we look at 8, we want to do the same thing. We first want to change these to improper fractions. I would say 8 times 8 plus 7 gives me 71. And then 8 is going to be my denominator. We keep the denominator the same. 6 times 3 plus 5 gives me 23 over 6. Then this is where I've got to get common denominators. So I'm looking at 8 and I'm looking at 6 and looking at what is a common denominator between 8 and 6. And I'm thinking about multiples of 8, 16, 24, 32, and then I'm thinking about multiples of 6, 12, 18, 24, 30, and 24 is going to be the least common multiple. That's going to be my common denominator. Once I know that, I need to look at what can I multiply 8 by that would give me 24, and that is 3. And when I multiply those, 71 times 3 gives me 213 over 24. And I'm adding these. I move to the second fraction, and I want the bottom number to be 24. There's a 6 there. But if I multiply that by 4, I could make 24 in my denominator. 23 times 4 gives me 92, and then I have 24 in my denominator. These are my new fractions. If I add the numerators together, 213 plus 92, I get 305 for the numerators. And then I have to keep the denominator the same at 24. Now this is where I'm going to change this back to a mixed number because I started with mixed numbers, so I want my answer to be in a mixed number. And I do that by long division. How many times will 24 go into 30? It will go into 30 one time. 24 times 1 is 24. 30 minus 24 is 6. And then I need to bring down my 5. And then I do repeat that process. I say, well, 24 will go into 65 2 times. And then I'm going to actually multiply those values together. 24 times 2 is 48. And then I need to subtract. 65 minus 48 is 17. And that makes my value 12 is my whole number. 17 is my numerator. And 24 is my denominator. So 12 and 17 over 24. And 17 over 24 is not going to reduce. 17 is a prime number and it doesn't go into 24. So that would be my final answer. I'm going to do the same thing for number 8. I want to first change those to improper fractions and then look for common denominators. I multiply 12 times 2 and then add 1 to get 25 over 12. And we're subtracting this time. And then I'm going to say 1 times 24 plus 5, that's going to give me 29. And that's going to be over 24. These are my new fractions. And I want to look for a common denominator between 12 and 24. So I'm thinking about multiples of 12, multiples of 24. What number occurs in both lists? The smallest number. And that would be 24. 24 would be my common denominator. This first fraction has a denominator of 12. I want that to be 24. I would need to multiply that by 2 in order to get the denominator to be 24. I go straight across. 2 times 25 is 50. And then 2 times 12 is 24. I'm subtracting. And then this fraction, 29 over 24, it already has the bottom number that I need. I wanted that bottom number to be 24. It's already a 24, so I just keep it the same. I don't have to do anything with that. Sometimes people say multiply by 1, and that's fine because it doesn't change the value at all. And I want to subtract, and I get 50 minus 29, and so that's 21. Over 24. So I get 21 over 24. Now, we've been saying this whole time, my rule is that if I start with a mixed number, I want to end with a mixed number. But in order for that to happen, you have to have an improper fraction. In order to change it to a mixed number, it has to be an improper fraction. It has to be more than a whole. In this case, this is a proper fraction. The smaller number is on top, so it cannot be changed to a mixed number. A mixed number is a whole part and then a fraction of a piece. This is not quite a whole piece, so it doesn't have the whole number component to it, which means I can't change this to a mixed number. I just have to reduce. Occasionally, that may happen when you add or subtract, and this is a proper fraction. It's not an improper fraction. So I cannot change it to a mixed number. I have to leave it in this form. However, it can be simplified. I can reduce this fraction by 3. So even though I'm not changing it to a mixed number, I still have to write my answer in simplest form. 21 divided by 3 is 7. And 24 divided by 3 is 8. So this would reduce to 7/8. Not a mixed number, but just a proper fraction, 7 over 8. All right. Most of the time when we were working with mixed numbers, we got improper fractions, so we changed them to mixed numbers. In this case, we did not get an improper fraction, so the only thing we can do is just reduce it if it needs to be reduced. We can't change this to mixed number.